video is going to be the second part of Chapter 11, the introduction to risk, return, and the cost of capital. So this video is going to focus on risks. So there are two measurements of risk. The first is variance, and the second is standard deviation. The variance is the average value of squared deviation from the mean, and the standard deviation is just the square root of the variance. So why the variance or the standard deviation is a measure of risk? Because both of them measures the volatility. So think about risk. The risk means uncertainty. Say your income can be very devised, then that means that embeds a risk rather than certainty of the income. And because of this, we use those measures, the variance and standard deviation, to see how volatile your income or your asset return can be. Okay. So let's look into this. If we put the annual return of common stocks, bonds, and bills into a historical graph, you can see the common stocks have a very diverse returns. Okay, so the return can be very negative. So in 1 year, it's between negative 45 to negative 40%, and in 1 year, it can be positive 45 to 60%. The return, the annual return of common stock is very devised. Okay, and for the bonds, it's more concentrated. Okay, so most of the years, the annual return of the bonds is between 0 to 5%. So in 1 year, it can be as worth of negative 15% to negative 10%, and in 1 year, it can be very high to 40% to 45%, but it's more concentrated comparing to the common stocks. And for the bills, for the treasury bills, it's the most concentrated one here. You can see almost every year are between 10% to 0%, and the only very rare circumstance it can be negative 5% or higher to 15%. Okay, so the more concentrated your return is, the more certainty you have on your return, and that means less volatile and means less risk. So in other words, we are saying the treasury bill have the least risk, and the common stock have the highest risk on the returns. Okay, so we use the standard deviation as a measurement to see how diverse your return can be, and the more diverse and means more volatile, and it also means more risk you are having with your return. So let's look into a numeric example. Suppose there are 4 different rates of return of equal probability. So there is 25% of chance you will get a positive 40% of return, 25% of chance you will get negative 20% of return, and 15% of chance you will get a positive 10% of return. Okay, so those 4 situations are of the equal possibility. Then we can calculate the expected return, which is the weighted average return based on the probability of each outcome. So 40% of return times the probability of 25% plus the 10% of return multiplied by 15% of the probability plus the 25% probability times the negative 20% of return. And the weighted average, you will get it 10%. So the expected rate of return is 10%. And then you can calculate what's the deviation from this expected return in each circumstance. For the positive 40% of return, you get 30% deviated from the expected return of 10%. So 40 minus 10, you get 30%. So 30% deviated. For 10%, it's the same as the expected return, so it's 0 deviation. And for negative 20%, it's negative 20 minus 10%, which is negative 30% of deviation. And then you square the deviation here, 30% squared you get 900, and 0 squared, you get 0, negative 30 squared, you get 900 squared. Sorry, you get 900. So adding up the square deviation, you get the 1800, and you divide it by 4, so you get 450, and that's the variance. Okay, so the formula for the variance is the average of squared deviations. Okay, you adding up all the square deviations, and you divide it by the number of circumstances. So 118 divided by 4 gives you the variance of 450. And then to calculate the standard deviation, you're just taking the square root of the variance. So the square root of 450 is about 21.2. So the standard deviation is about 21%. Okay, so this is the calculation of the variance and the standard deviation. Okay? If you are not familiar with this process, maybe go back and check your math book or do some more examples as practice. So next, we can calculate the rate of return for each year, okay? And we can calculate the deviation from the average return, okay? So from 2010 to 2015, we can calculate the annual rate of return for each year, and the average return for those 6 years is 12.47%. Okay, so we can get the deviation for the rate of return for each year. So for example, for 2010, the rate of return is 17.86 minus the average of 12.47. So the deviation is 5.39. You square it, you get a square deviation of 29.02. Okay, you do this for every year, you adding them together, you get 765.23. Okay, and you divide it by the number of years, you divide this number by 6, you get the average of squared deviation, which is the variance. Okay, so the variance is 127.54. And then to calculate the standard deviation, you take the square root of this variance. So the standard deviation is 11.29%. Okay, so this is the example. You calculate the average return from year 2010 to 2015, and the variance and standard deviation of the return on those 6 years. Okay, and also we can do this for each company or for each industry. Okay, so for example here we calculate in those 6 years the average variance, the standard deviation is 11.29. Okay, and for here we can calculate the standard deviation for US Steel company or for the SP 500 as the market index. Okay, and we can see here for the companies the standard deviation is higher than the market standard deviation. The reason for that is usually the larger the portfolio, the more diversified the portfolio is, the lower the risk and the lower the standard deviation. And we'll talk more about this later. Okay. So if we have different companies, we have multiple stocks in the portfolio, we can calculate the portfolio rate of return using this formula. So using the fraction of the portfolio for each asset multiplied by the rate of return for each asset and adding them together. Okay, in other words, we are calculating the weighted average rate of return for each asset. Adding them together gives you the portfolio rate of return. Okay. Using this example, if we have all those different companies, we use their return, okay, not the standard deviation here, but we can use the return for each of those stocks multiplied by its fraction in the portfolio to get the portfolio rate of return. Okay. So let's look into a two asset example. Suppose there's gold and there's auto stocks. Okay, and there are going to be 3 scenarios in the future: the recession, normal, and the boom. Each have the probability of 1/3 So the probability of happening to be a recession in the future is 1/3, normal is 1/3, and the boom is also 1/3. Okay, and for auto stock, in the recession, the return is -8%. I just ignore the percent sign here. In the normal, the return for the auto stock is going to be +5%, and in the boom market, the return is going to be 18%. Okay, and for the gold stock, if there's going to be a recession, the gold is kind of very conservative investment, and it's going to save you the money. So it's the return in recession will be 20%. In normal, it's going to be 43%, and in the bull market, the gold stock will have a -20% of return. Okay, so we can calculate the rate of return. We can calculate expected return for the stock, for the auto stock and for the gold stock. So for the auto stock, the expected return is 1/3 probability of recession multiplied by the -8 plus the the probability of 1/3 multiplied by the positive return of 5% plus the 1/3 probability of 18%. Adding them together, you get an expected return of 5%. Okay, and then to calculate the variance, so if it's in recession, the deviation from the expected return is -13%. Okay, you square it, you get 169. If it's in normal, the deviation is 0, so the square is also 0. If in the bull market, the deviation is 13, 18 minus 5 gives you 13. And the square deviation is also 196. Sorry, 169. Adding them together, divided by 3, because there are 3 scenarios, or you can say the probability of each scenario is 1/3. Okay, so divided by 3, you get the variance of 112.7. You take the standard deviation, you get 10.6%. Okay, so this is for the auto stock. You get 5% expected return, 112.7 for the variance, and 10.6% for the standard deviation. Okay, so I will recommend you to do the exercises by yourself. You can do the same thing for the gold stock. For the gold stock, the standard deviation is 268.7, and the standard deviation is 16.4%. So it's the same process here. Okay. Next is something interesting. So say in the portfolio, we are going to hold 25% of the gold and 75% of the auto. So what's going to be the portfolio expected return, portfolio variance, and standard deviation? So again, if we have the 25% gold and 75% of the auto, okay, so the portfolio return is going to be -1%. Okay, why? Using the earlier formula we have here, the fraction of portfolio in the asset multiplied by the rate of return of asset, adding them together. Okay. So here this will just be the 75% multiplied by the -8 plus the 25% multiplied by 20. Okay, and that will give you the portfolio return of -1%. Okay, for the recession. And similarly to the same calculation for normal and for boom, you get the positive 4.5% return for normal and positive 8.5% return for boom. Okay. Okay, so you get the expected return for the portfolio in those 3 scenarios, and then you can calculate the expected return for this portfolio. The way to do that is the probability times the portfolio return and adding them together. Okay, so 1/3 multiplied by -1 plus 1/3 multiplied by 4.5% plus 1/3 multiplied by 8.5%, and you get expected return for this portfolio is 4%. Okay, So this is one way to do it, to calculate portfolio return, but there is another way. Okay, the other way is, you know, the uh, the rate of return for the auto stock is 5%, okay, and the expected return for the gold stock is 1%, okay, and you know it's 25% of the gold stock and 75% of the auto stock. You can just use that formula for the portfolio return, applying it by 5 multiplied by 75% plus 1 multiplied by 25%. Okay, you should also get the 4% portfolio return. Okay, so there are two ways to calculate this expected return. And then after you getting the expected return, you need to get the variance. Okay, you cannot using those two numbers to calculate the portfolio variance here. Okay, the way to do it is, you know the expected return for the portfolio is 4%. Okay, you use -1 minus 4. So how much the return is deviated during the session. So you get -5. And in normal times, it's 4.5 minus 4, okay? And in boom, it's 8.5 minus 4, okay? You need to get it squared, okay? So -1 minus 4 squared, so that -5 squared is 25. 4.5 minus 4 squared is 0.5 squared is 0.25. Okay, so you get everything squared adding together and divided by 3. Okay, because there are 3 scenarios of equal probability. Okay, and that gives you the variance of the portfolio is 15.2. Okay, you take the standard deviation. The standard deviation of 15.2 is 3.9. So you can see the variance for the portfolio is much lower than the variance for each of those stocks, and the same for the standard deviation. Okay, so this is kind of interesting because we are mixing two different stocks, and the portfolio return is somewhat in between. Okay, however, the portfolio risk is much lower than each of those risks. We can split this into, we can try more combinations here, and we call this the sensitivity analysis. Suppose we hold all stocks in autos, say it's 100%, okay, and then we have 0 for gold. Or we have 80% in autos and 20% in gold, 16% in auto, 40% in gold, and so on. Okay, and for each of those combinations, we can calculate the portfolio rate of return. Okay, and we can calculate the expected return for this portfolio and the standard deviation for this portfolio. Okay, so you can try to just pick one or two combination here and try to replicate this calculation by yourself. Okay, so this is something I'm going to test you. I may ask you what's going to be the portfolio rate of return, or what's the portfolio risk standard deviation, giving you two assets. So you need to understand and to replicate this kinds of calculation. So back to this, we can calculate the standard deviation and the expected return for each of those portfolios, and we can plug those two, the return and deviation, into the graph. Okay, say for example, for the first combination, if it's 100% auto and 0% gold, we have the expected return of 5%, standard deviation of 10.6. Okay, for the portfolio C, we have 40% gold and 6% auto. We will have 3.4% expected return and 60.6 of the standard deviation. Okay, we plug each of those into the graph. The x-axis is the standard deviation, and the y-axis is expected return. Okay, so each point is representing one combination here, and we can see here the return, expected return of the portfolio is getting down, okay, from A to F. However, the standard deviation is decreasing and then increasing. Okay, so it's like kind of like a, a shifted V shape here. Okay, and if you are an investor, you want to invest your money. Okay, you want to choose a combination of your portfolio. Okay, so obviously you want higher return and you want to have lower risk. Okay, in other words, there is no point, there is no reason for you to choose portfolio D, E, or F. Okay, because comparing portfolio B and portfolio D, they are about the same risk. However, B is giving you much higher return. Okay, similarly, if you are choosing portfolio E, you are getting much lower risk comparing to portfolio A, but about the same return. Oh, sorry. So you are getting the same risk, but a much lower return. Okay. So there is no reason for you to choose portfolio D, E, or F. Okay. But for A, B, and C, so if you really like high return and you don't mind taking extra risk, you may want to choose portfolio A. Or if you are very much risk averse, you don't take much risk, okay, and you are not that return presumed, so you will here choose portfolio C, which gives you a kind of lower return but much lower risk. Okay, so there are different combinations of the risk and the return here, and those, depending on your personal preference, you will choose the portfolio you like or the combination of stocks you like. Okay. However, the key message here is that when we are combining two assets, okay, because you see the nature of those two assets, say for one stock is going to increase your income in a boom recession, and for the other you are going to have more income or more return in the recession. Because of the nature of those stocks, okay, even if they are not going the exact opposite way, because they are having different returns, you are kind of diversified your portfolio, and then in that you are lowering your risk. Okay, so when you are combining you have multiple stocks in your portfolio, the benefit is that you will have a more diversified portfolio, and you will have less volatile in your return, and that gives you lower risk overall. Okay, so we can actually put put your risk into two parts. Okay, and we call the strategy designed to reduce risk by spreading the portfolio across many investments. We call it the diversification, and there are two risks for the investment. So the risk factors only affecting a certain fund, we call it the specific risk. And this risk can be diversified if you have many stocks, a lot of stocks in portfolio. And the other part is the market risk, which is the economy-wide sources of risk that affect the overall stock market. Okay? And we also call it the systematic risk. And this is the risk that affecting all the companies in the stock market. So this cannot be diversified no matter how many stocks you have. Okay. So if we look back into this graph, we'll say for the companies, if we have a very diversified risk, the risk level, the standard deviation can go from A to C here. However, we cannot go back to zero because there's still some risk. The market risk cannot be diversified away no matter how many companies you are holding your portfolio. Okay, and if we put that into a graph, it will be like this. So the x-axis is number of stocks you have in portfolio, the y-axis is standard deviation. So the more stocks you have, the lower risk you are going to get. Okay, so the risk level is getting lower and lower, however, it's converting to a certain level. So we can break into two parts. So this part, when it's getting lower, it's the specific risk due to the risk of each company. So each company have a chance of getting default or getting some kind of disaster, say there's a fire in the factory or whatever, causing a specific risk to this company. Okay, this is diversifiable. The more companies you are holding, the lower specific risk you will get. However, this risk will convert into a certain level, and that's the market risk that cannot be diversified away. Okay, so a few key messages. First, some risks look big and dangerous, but really they are diversifiable. So you invest in a company, you are worrying the factory of that company can be just on fire or burned away. So this is a very large risk. But if you are holding many companies, so the dangers of on fire will be diversified, so it can be diversified away. Second, market risks are micro risks. So the market risks is the risk that cannot be diversified, and they are more likely to be due to micro reasons. So for example, if there is such for the moment there is such a COVID-19 crisis, so it's affecting every industry, and this risk cannot be diversified away. Okay. And lastly, the risk can be measured, and the way to measure it is to see how volatile the return can be. So we are using the variance and standard deviation to measure this risk. Okay, so that's all for chapter 11.